So if I was comparing these, this one, the ounces would be more precise because it is the smaller unit. All right, so a non-example, if I did the same thing, it'd be 4 pounds to 67 ounces. And again, I put a Z there on accident, but I'm not going to erase it. Okay, that's supposed to be 7. 4 pounds to 67 ounces. This would be a non-example of more precise. All right. All right. This is chapter 10, lesson 1, precision and accuracy in measurement. Your objective is to explore the difference between precision and accuracy in measurements, to find the greatest possible error, GPE, and the relative error of a measurement, and to measure to a given unit of precision. Also to apply precision in significant digits in computations. So if you notice the word precision is in there a lot, that's actually going to be our very first definition. So in your box, I want you to write precision. Okay, so what does the word precision mean? It is the quality or condition or fact of being exact. So it's being exact and accurate. So let's go ahead and write that down. Okay, so read this out loud, not out loud, read this to yourself. Nancy checks the weight of some vegetables. She tries 2 different scales in the market. The first scale weighs to the nearest pound. The second scale weighs to the nearest ounce. The vegetables weigh 4 pounds on the first scale and 67 ounces on the second scale. If the vegetable actually weighs 4.5 pounds, which measurement is more precise? So, precision. It always talks about math is referring to the smallest unit of measurement. The smaller the unit, the more precise it is. So let's look at our measurement. We have pounds. We have pounds and we have ounces. So if I were to compare 4 pounds to 67 ounces, that's supposed to be 7. Okay, so in math, for precision refers to the smallest unit of measurement on the measuring instrument. The smaller the unit, the more precise it is. Okay, so I put that in the facts or characteristics. If you need to, you can pause the videos to keep up. So let's go ahead and talk about an example. Okay, so first, if you haven't noticed, someone woke up from their nap. Before I tell you what accuracy means, I'm going to give you an example because precision and accuracy, a lot of people get that mixed up. So accuracy is, let's talk about precision first because you already know precision. So this is a dartboard, that red circle up there. If this is my dartboard, if I were to say something is precise and I were to say, I hit the dartboard right here. Now, that's not in the center of my dartboard, but that is precise because it's all around the same area. It's in a small area. So that is precise. Accuracy visually, if you were to see accuracy, I'm going to do a different color. Accuracy would mean that it is near the center, but it doesn't have to be in such a small area. It's accurate. So let's talk about the definition of accuracy. Mathematically, refers to how close the measurement is to the actual value. Well, on a dartboard, it refers to how close it is to the actual target. So facts or characteristics. Sometimes precise and accurate might have they don't mean the same, but sometimes more precise does mean more accurate, but not always, and you need to keep that in mind. If I ask you if it's more precise or more accurate, they might not be the same answer. So, for example, and of course your non-example would be the opposite. This would be an example of something That is non-example. Okay, so let's go on to our next definition. For example, if I were to use this exact same example that I used earlier, and I were to talk about which is more accurate, because that's what the second question asks. Well, the vegetable weighs 4 pounds. Oops. 4 pounds. 4 pounds equals 64 ounces. And the next one is 67 ounces. Okay. Now, we already said that this is more precise because it is close, because of it's measured in ounces, and ounces is a smaller unit than pounds. Now, let's talk about accuracy. It refers to how close the measurement is to the actual value. Well, if the vegetable actually weighs 4.5 pounds, so 4 and 1/5 pounds, 4 1/5 pounds equals about 67 2/10 ounces, which means that in this case, precision and accuracy are the same. So I know that's kind of funny to put in your example box, but I want you to go ahead and put this in your example box.
Hi. I thought y'all deserved a little break.
And because, she can't sit still for nothing. So we're going to go and move rooms. Okay, so the last definition you're going to need to know is the greatest possible error, GPE. It is considered to be 1/2 of the smallest unit that the measuring instrument can measure. So, you need to write this in your notebook. You also will need to write the key concept. So, if we look here, the vegetables weigh 4 pounds on the first scale and 67 ounces on the second scale. 67 ounces is the smaller unit, so that's what we're going to be using. So, it says that it's 1/2 of the smallest unit. So that means that if it is 67 ounces on the second scale, the GPE of her measurement is 1/2 ounce. So that means it could be 67 minus 1/2, which is 66.5 ounces. Or 67 plus 1/2, which is 67.5 ounces. So that means that the vegetables could weigh from 66.5 ounces to 67.5 ounces. That's all that means. That's how you find the GPE, greatest possible error. So let's talk about absolute error and relative error. No measurement is exact. We know that. The uncertainty in any given measurement is referred to as an error. Their error does not mean a mistake. You'll also need this in science class, and you'll also need to know this when you're moving houses like I am. So I like all my pictures to be straight that are hung up on the wall, and if they're not, then my husband gets in a lot of trouble. Okay, so there's always error though when you're hanging up pictures, especially if you're not using the straight edge. If you're not going to measure from a straight edge, then you can, just by visually looking at it, there's going to be a lot of error. So the absolute error of measurement is the actual size of the error. It can be represented by the GPE. The relative error of a measurement is the absolute error in relation to the correct value, or to the measured value if the correct value is not known. So there are equations for this, and we're going to go on to the next slide. Okay, so now you're going to have to find the absolute error and the relative error for Nancy's measurement. Use your results to explain which measurement is more accurate. So, I want you to use these equations that's given to you. Actual weight minus measurement equals absolute error. And I want you to do it for the first scale and the second scale. And I know you can do it on your own because you should know what the actual weight is. For the first scale, your actual weight's 4 pounds, but you need to make sure that it's in ounces. And I give it to you because there's 16 ounces in 1 pound. And then minus the actual measurement equals absolute error. So go ahead and pause the video and try to see if you can plug in the numbers to find the absolute error. So you should have done a 1/2 ounce divided by 67 ounces because it was given in ounces. So it'd be about 7 thousandths. So that means it's about 0.7%. So if I look right here, it even gives me the answer for which one is more accurate. Well, the one that's more accurate is the one that has a smaller relative error. And the one that has a smaller relative error is the second scale. Alright. Okay, so if you plug the numbers in correctly, you should have got for the first scale, your actual weight for the first scale is 67.2 ounces, 67 2/10 ounces, and that's for both of them, minus the measurement you did, which is 64 ounces, 4 pounds, and then it equals 3 2/10 ounces. So the actual weight is 67 2/10 ounces minus the measurement for the second one was 67 ounces, and that gives you 2/10 ounces. So now I want you to find the relative error. Relative error is always in percent. So once you get your decimal value, you're going to have to change it into a percent. So I'm going to do the first scale with you. First scale is the GPE, the greatest possible error, which is always going to be a 1/2. So that means I can put, 0.5 pounds, 1/2 pound, divided by the given measurement. The given measurement is 4 pounds. That's what it gave us for the first time. Equals. So in your notebook, you're going to do 0.5 divided by 4. And make sure you put your decimal right there. Bring it up. So 4 goes into 5 one time. Bring down a 0. 4 times 2 is 8. 10 minus 8 is 2. 4 goes into 2 5 times. So you should have got 125 thousandths. So 125 thousandths equals, if I were to change that into a percentage, remember all I have to do is move my decimal 2 times to the right, and I get 12.5%. That's, oops, you can't see it, so I'm going to write it right here. 12.5%. So I want you to go ahead and pause the video, and I want you to do the second scale on your own. Okay, so here's a few examples. I'm going to do 2 with you, number 2. Give the GPE in the percent of relative error to the nearest 1/10 of a percent. So the GPE is always going to be a 1/2. It just depends on the unit of measure. So for number 2, it's 72 feet. So that means my GPE equals 1/2 foot. That's all that means. So now I need to find the percent of relative error. To find the relative error, I have to do GPE divided by given measurement. And then whatever I get there, I need to change it into a percentage. So my GPE is 1/2 foot. My given measurement is 72 feet. So I have to do a 1/2 divided by 72. So y'all are going to be practicing your division a lot. Top in, bottom out, 1/2 divided by 72. And you should have got 0.007, which is going to equal, to change it into a percentage, I just move my decimal 2 times to the right, and it's going to equal 0.7%. Oops. 0.7%. So my 2 answers that are going to go in the box when I circle my answers is going to be These two answers. And that's a percentage, not a 9. So I want you to go ahead, do 3, 4, and 5. And then you can put everything up. And then I'll answer any questions that you have tomorrow.